Hello and welcome to my YouTube channel, people. The place where we take the concepts of science from complex to simple. And today we're beginning an entirely new series that says how to balance chemical equations. Alright, this one is going to be absolutely in-depth, explanatory, and filled with so many relatable examples that will make you understand every concept we want to talk about. So without any further ado, let's get into what we have and learn how to balance chemical equations. So first things first, I want you to start off today's lesson by imagining a bit with me. You're a chef in a kitchen and you want to bake a cake. The recipe says use 2 cups of flour, use 1 cup of sugar, and use 2 eggs, and then a teaspoon of baking powder. You have everything available as shown in the recipe over here. Now, what now happens? You now said instead of doing all of that, a mistake now came up that made you to add 5 cups of flour mistakenly and only 1 egg instead of using the original recipe. What do you think will happen? Well, you're going to enter the Guinness Book of Records, and this time it's not going to be for baking the world's best cake. It's going to be for having the worst mistake ever in the history of baking cakes. The cake is going to be a complete flop. Now, why did I give that example? I gave that example because that is what happens in chemistry when we do not balance our equations. Things are going to go wrong. That brings me to the next question that we need to tackle. What is a chemical equation? Well, a chemical equation is simply a sentence in chemistry. A sentence in chemistry that tells us, number 1, the substances that are reacting, which are the reactants, and the substances that are formed, which are the products. So when you hear the term chemical equation, what we are simply talking about is simply a sentence in chemistry that tells us or identifies the substances that are reacting and the substances that are produced. Now that we have that out of the way, there is an important concept you also need to grasp. Just like the ingredients in cooking, when you want to cook, there are things that you call your ingredients. Those are the things you combine together in order to arrive at the final recipe. Now, just like the ingredients in cooking, the number of atoms that go into the reaction must be equal to the same number of atoms that are coming out. For instance, now let's say you're making a cup of tea. You have your milk, you have your sugar, and you have water. Okay, so maybe you have some beverages on hand, maybe Milo or Bonvita or whatever it is. When you combine everything together, you're going to end up with a cup of tea. Now, that cup of tea is simply a combination of all the ingredients that you started with. There is no new ingredient that magically appeared inside the cup of tea. Now, that's exactly what we are saying. Just like in the process of cooking, the number of atoms or ingredients that go into the reaction must be the same as the number of atoms that are coming out. Now, that brings us to something that is called the law of the conservation of mass, which we're going to talk about more extensively as we progress in this series. There is no atom that is magically disappearing or appearing during a reaction. They are just rearranged. Now, that brings me to the concept of what I want to talk about next. You can see a stack of Lego blocks at this point in the screen identified. Now, this stack of Lego blocks can be used to make a variety of things. You can arrange them to form a brick wall. You can rearrange them to form a toy house, whatever it is you want to create. It is just the process of rearranging them that forms something entirely new. Now, here is the catch. In the process of rearranging them, no new block is disappearing and no new block is appearing magically. It is just that you are rearranging them to form something new. That is what a chemical reaction is all about. Using the products or the substances that you have available to form new things. So now that we have that in place, it is important to know the reasons why we balance our chemical equations. We balance our chemical equations to ensure a number of things. First of all, we want to follow the rules of science. It is a rule that has been set in place that before you treat any chemical question or any chemistry question, it is important that if there is a chemical equation placed there, let it be completely balanced. The next reason is so that we can get the right amount of substances, and then thirdly, so that we do not get surprising results, just like the cake analogy that we saw earlier on in today's video. So here are some relatable examples of chemical equations that you can relate to in our daily lives. Example number one, when you're making your noodles, which is the process of cooking and recipe. If your chemistry reaction is just like cooking noodles, then the reactants are your water, your seasoning, and the raw spaghetti that you put inside the pot or whatever it is you're using to cook. Now we have the water over here. We're adding a bit of seasoning over here, and then we have the noodles, raw noodles itself. When you combine all of this together, you're going to end up with a new product that has been formed from the process of combining all of these reactants together. So if we're looking at the process of cooking and recipes just like a chemical reaction, then these guys over here are our reactants. Now imagine this. Instead of using the designated amount of seasoning that is inside the pack of noodles, imagine you now used way more than was recommended. What will happen? It's a bad idea, first of all, and then it will tell you that balancing tells you the right mix or the right amount of substances to use. So that brings us back to the importance of balancing your chemical equations. It is so that you do not get results that are inappropriate. I'm sure this lesson has been educative for you. If it is, please do well to like, share, and subscribe so we can reach more people. Example number two is the example of charging your phone. Now, if you're watching this video on a mobile device, maybe a phone or a laptop, I'd like to let you know that the possibility of you watching this video was made available because of a chemical reaction. That chemical reaction is the process of charging your mobile device, especially your phone. You see, the process of charging your phone involves battery reactions that are going on inside your phones. And those reactions actually involve electrons that are moving between chemicals. Now, here's the catch. If the reaction is not balanced, or if what is going in is not equal to what is coming out, what happens is that your phone might not charge properly and then it begins to overheat. That is why manufacturers of mobile devices and phones have a specific range of current that is recommended for charging your mobile devices so that there will not be a disruption in the process of charging your devices. Here is the next example. The next example is the process of breathing. If you've been watching this video from the start up until this moment, then I introduced to you this concept. The process of breathing is actually a chemical reaction, because let's face it, your lungs actually do chemistry. Every day, every second, and every moment, you breathe in, and in the process of breathing in, you're taking in oxygen, and in the process of breathing out, you're giving out carbon dioxide. So oxygen over here and carbon dioxide, CO2, coming out of you. The thing is, there is a chemical equation that shows the balanced proportion of the amount of oxygen that you are taking in and the amount of carbon dioxide that you are giving out. And that process is called the process of respiration, which we're going to talk about extensively as we proceed in this series. So what happens when equations are not balanced? First of all, it results in the wrong results for chemical experiments. Remember, we talked about the concept of noodles earlier on. If you use a higher amount of seasoning than the recommended portion, then you will get a result that is different from what is expected. The next thing is that dangerous reactions can happen if too much of a substance is used. And then thirdly, you can have incorrect answers in examinations. And then finally, the failed understanding of real life science results when you do not balance your chemical equations properly. So you see, balancing a chemical equation wrongly or getting the answer incorrectly is just like telling a story and then you're missing half of the characters involved. it just will not make any sense. So here is a good example. If I ask you to tell me the story of David and Goliath. Now, David and Goliath is an epic story known by virtually every person you find on the earth today. Now, it's a story that involves two main characters, David, which is a shepherd boy, and Goliath, which is a Philistine warrior, even from the days of his youth. Now, if I hear you telling me the story of David and Goliath, and then I hear you involving another character named Michael Jordan, I'm going to be very confused, first of all. And then next, I'm going to be surprised because when David and Goliath came together, they didn't come to play a basketball match. They came to fight. They came to go to war. So I'm going to be confused because how is Michael Jordan finding expression in a battle of swords and spears? It just will not make any sense. That's the same thing that happens in a chemical reaction. When the equation is not balanced, it doesn't make any sense. All right, so now that we have that out of the way, it is important to also know why you must master this skill. First of all, balancing chemical equations are one of the first major topics that chemistry examinations love to test. There is no way you will write a chemistry examination of any sort and the ability to balance chemical equations will not be tested. It just has to happen. Next is you will need this skill to understand acids and bases. You will also need this skill to understand salts, redox reactions, electrolysis, and more. In fact, if there is any topic of chemistry that involves calculations, particularly the topic of stoichiometry, you're really going to need the ability and the skill of balancing chemical equations. The third is once you master this skill of balancing chemical equations, chemistry gets way easier. I can tell you this for a fact, and I'm speaking from experience. From the moment I learned how to balance chemical equations, it just opened up an entirely new world of science to me. I began to see things from a different perspective, and that's what I want for you, even beginning from this video. So let's begin by learning how to speak chemistry fluently. How? By learning how to balance our equations properly, confidently, and like pros. So like I said, this series is beginning with this video, and every video has been broken down step by step to explain every concept in-depthly and with relatable examples that you can understand. So up next, we're going to be looking at the foundations of chemical equations. I want you to stick around and I want you to stay tuned when that episode arrives. Up until then, my name is David, and all we do here is to take the mystery out of chemistry so you can make history. I'll see you in the next video, and up until then, please like, share, and subscribe for more educational content. Thank you.